Today we start a new section, 0.4 trigonometric functions. So everything that we've done so far with trig was for acute angles. Now we want to try to make this work for any angle. In order to do that, I'm going to look at an angle, theta, and I'm going to turn this into a triangle. So I drew this black line coming down from my opposite side of theta. So I took this angle and made it into a triangle by drawing this third side. I can figure out the height of my triangle just by looking at what it would be on the y. I can figure out how far it goes out on the x just by looking at whatever number this would be. In order to find my r, I would have to use the Pythagorean theorem. R squared equals x squared plus y squared. Take the square root of both sides, and I get r equals the square root of x squared plus y squared. Once I have that, I know all my sides of this triangle. So now I can use my trig functions in order to find what this angle would be or what any of the sides would be. So the first function would be the sine function. The sine would be opposite over hypotenuse, which is r, so y over r. Cosine or cosecant would be the opposite, r over y, hypotenuse over opposite. Cosine would be x over r. Secant would be r over x. And tangent would be y over x, with cotangent being x over y. If I look at this point where it all comes together, it's the point x, y. So once I look at that now, I can tell that based off of just this point, I will be able to come up with all of my trig functions, or those ratios that we had been working on before. So here we have a point -3, -2. It tells me I need to find the sine, cosine, and tangent of that angle. So in order to do that, all I have to do is find first the radius, because if I think about this on a coordinate plane, then I go back 3 and down 2. This is where my point is. And I have a radius coming out to here. And I can form this triangle. So we know that this distance of this side is 3. This distance here is 2. And I would use that to find my radius. So the first thing I have to do is find my radius. Radius equals x squared, so -3 squared, plus y squared, which is -2 squared. That gives me the square root of 9 plus 4, which is the square root of 13. I don't want you to simplify that and give me some decimal. Just leave it as the square root of 13. So I have my hypotenuse now. Now I just need to use what I learned in the last part, which is sine of theta equals my y over r. Cosine theta is equal to x over r. And tan theta is equal to y over x. So sine theta would be y, which is 2 over 13, or over the square root of 13. So I would have negative 2, because it went down 2, over the square root of 13. Remember, I can't have a square root in the bottom, so I multiply by the square root of 13 on top and bottom to rationalize that denominator. Gives me negative 2 root 13 over 13. For the next one, it's my x, which is negative 3 over square root of 13 multiplied by root 13 on top and bottom. And I'm left with negative 3 root 13 over 13. Let me move this stuff down here so we can see it better. And lastly, I have tangent. Tangent is just x over y, or y over x. Sorry. So that would be negative 2 over negative 3, which is just 2 over 3. And that's my final answer. So I found the sine, cosine, and tangent. Trig ratios have been defined for all angles. But our modern applications of trig only deal with functions whose domains consist of real numbers. So we won't have any complex numbers or imaginary numbers. The basic idea is quite simple. If t is a real number, then the sine of t corona, is defined to be the sine of an angle of t radians. So as soon as I see sine t, that tells me that I have an angle of t radians. This is why we're only working with radians now instead of degrees. Cosine t is defined to be the cosine of an angle of t radians. So as long as t is a real number, then we know that this is true. Trigonometric functions in the unit circle. Recall that our unit circle is the circle of the radius 1, which is centered at the origin, 0, 0, whose equation is x squared plus y squared equals 1. In other words, that's our radius is 1. The unit circle is the basis for the most useful description of trig functions of real numbers. I'm going to show you how that's true. When we look at the unit circle, we have a point x, a point xy. That's this point P here. P is xy. And the distance from P to the origin is always 1. Our radius is always going to be 1 because our circle has a radius of 1. Then we can find our trig functions using the point P. So let's start with our most basic ones. If I'm using this point P, then I have my x and y. My x is going to be how far back I am. My y is going to be how far up I am. So I'm forming this triangle here. So if I'm going with sine theta, this is my height y, this is my point x. This is my r, which is 1. Now I just go right back to my old ratios. Sine theta is equal to y over 1. That's just y. Cosine theta is x over r, which is 1. that gives me x. My tangent is y over x. The important part to note here is that when I look at this now, my sine is just y. My cosine is just x. That tells me that whenever I'm looking at a point on the unit circle, whatever my x is the cosine of theta. Whatever my y is the sine of theta. Which is why the unit circle is so important. Because I don't need to do any calculations. As soon as I see this point, I know that the y is sine theta and the x is the cosine theta. Moving on from there, the cosecant is just 1 over y. The secant is the flip of the cosine, 1 over x, and cotangent is x over y. So just looking at the unit circle will give us every measurement that we need. So if we let t be a real number and p be a point where the terminal side of an angle of t radians is in standard position, meets the unit circle, which is kind of what we had in this last picture. We had a point P with cosine of t, or theta, and sine of t, which is y, and then it's got a radius of 1. Then we can find this angle. Our P then has the coordinates cosine t and sine t, just like I showed you. But then since we know that tangent of t is y over x, I can now say that my tangent is just sine over cosine. My cotangent is cosine over sine, because I just said that this was my x of cosine and my y was sine. Then my secant, now instead of just saying 1 over x, I can now say that's 1 over the cosine. And my cosecant is 1 over y, which is now 1 over the sine. So now we have all of our trig functions boiled down to 2 things. It all depends on your cosine and your sine. Everything else can be determined using those 2 trig functions. Once I have cosine and sine, I can find literally the rest of them. Domain and range. The domain of the sine function and of the cosine function is the set of all real numbers. The range of the sine function and of the cosine function is all of the real numbers between -1 and 1. So if I'm looking at the domain, my domain being theta or t, if I look at a circle, if I look at this circle, there's no point where my t doesn't exist. Sorry, that was a fantasy football phone call. I'm dominating. Okay. So there's no angle where it doesn't exist. Like I can just keep going around in circles and it's going to exist for any degree or radian measure I put in. So that's why our domain is going to be all real numbers. Our range, I dropped it on the wrong one. Our range of the sine and cosine is the set of all real numbers between 1 and -1. And I'll show you why that's true. So remember that my cosine is just my x's now. So if I go to any x on here, that point is covered. and it goes from -1 to 1. I can't have an x that expands out here because that's beyond the unit circle. So I can't have some x outside of here. It's all the numbers that are in between here. So there's a point in the blue for every x in between those two. Same thing with the y's. There's a point in my y's for every, on the blue, for every number between -1 and 1. My circle does not expand out to here at all. It stays inside of here. So if I just randomly pick that point there, I can draw a line through that, and you can see that it's touching the circle. So my line touches here and here. Now the domain of the tangent function is a little different. It consists of all real numbers except positive and negative pi over 2 plus 2k pi, where k is any number 0, 1, 2, 3, 4. The reason that we have to do plus 2k pi is because if I do 2k pi, that's going around the circle any amount of times. And I'll show you why it doesn't work for negative pi over 2 or positive pi over 2. For the tangent, if I'm looking at my circle, this would be pi over 2. This is negative pi over 2. Remember that this will be pi over 2 because I go pi over 2 counterclockwise. Negative pi over 2 goes clockwise. If I look at this point here, remember that my tangent of t is now defined as my sine of t over the cosine t. The sine is just the y, the cosine is just the x. If I look at this point here, this is the point 0, 1. So if I just plug those values in, that gives me tan t is 1 over 0. Can you divide by a 0? No, that would give you an undefined value. So that's why my domain does not exist at pi over 2. Same thing with negative pi over 2. If I'm looking at tan t, it's just sine of t over cosine t, which is y over x. So it's -1 over 0. Again, I can't divide by 0. So my domain does not exist at negative pi over 2 or at pi over 2. Now, if we're talking about the 2k pi part, all that means is that I go to pi over 2. So I'm going from here to here. And if I go with 2k pi, that's starting at this point and going around one full circle, and I end up back at here, which means I'm going to do 1 divided by 0 again. Still not going to work. Okay, no homework tonight. We're going to work through some examples tomorrow. So your homework is just going to be taking these notes. They're a little long this time. So just take the notes. Tomorrow we're going to work through more examples, and then I'll give you some homework on it.